is actually around 20 milliamperes. That's the maximum current an LED can handle. So if 20 milliamperes, we understand that 1 divided by 10 to the minus 3 is actually equal to 10 to the minus 3. So basically, that would be 1 times 1,000. And according to Ohm's law, V equals IR. So if the voltage equals the current times resistance, it means that to find the minimum resistance we should use, we have to divide the voltage by the current, right? And in this particular case, we are using 5 volts. We are using 5 volts here, the 5 volts. So 5 volts divided by 20 milliamperes. So let's divide by 20. We get 250 ohms. 250. It's actually 0.25 divided by the milli. So it's actually 250, which is times the 1,000. We get that. Now, if we also use 3 volts, the 3 volts resistance, that's minimum. So if we use 3 volts, we've got the 3 divided by the 20, obviously times 1,000, we get 150. So in the range between the 3 volts and 5 range, 220 looks reasonable, even though obviously it's lower than the 250 we are aiming for. But this works in hardware for us as well. We can actually calculate the resistance, the current, if you have time to use, let's say, multimeter here. You can use a multimeter from it and connect to it and find the resistance. But that's not what we're doing this moment. So 220 ohms works reasonably well. I'm just saying a minimum current, minimum resistance in this case, because obviously with a resistance of 0 volts, we will end up blowing, as we saw in the first lab that we did. I hope that answers your question, and for those who were interested as well. So you can actually use a value greater than this. It's not necessarily the maximum. You can use 300 volts. But if you use the higher the resistance, the lower the brightness that you are going to get. I mean, some change on that. It's tight stuff. So the higher the resistance, the lower the brightness of the LED that you are going to get. So 220 ohms is quite popular resistance value in terms of actual physical hardware. We're in the labs and using Arduino without these 220. Okay, back to the question, back to the lab sessions and back to the overview of going through things. So the idea is that if I'm not using variables, I'll have to make any changes to basically change from one LED to the other, or to use pin 12. So in this case, if I use an integer, let's say LED pin, and assign that to 12, and I can change all this to LED pin. LED pin, and you notice that now we can actually swap to the new pin. Oh, I used pin 9, so makes it easy. The whole point I want to show anyway. So basically, just change to pin 9, and it should work for us. So it starts playing for us. That's the benefit of using variables. Variables are just containers in memory. Now, when I zoom in terms of the writing, oops. It distorts things, but it works, right? So now what we have here is the concept of using these variables. But we notice that after in the loop, let's say after we, by default, the pins are set to output on the Arduino, and or the 80 mega 32HP chip, that's the one that we on the Arduino that we are using. So let's say afterwards, after the first run, we set the LED pin to be in 13. What you notice very quickly, let's say, let's change this to 2 seconds before turn it off. You notice that it will blink or it will turn on, turn off, and then this variable will be reassigned to pin 13. So this blink once, then it changes to pin 13, and then pin 13 starts blinking. It's quite faint because we have not explicitly labeled pin 13 as an output. So let's label 13 as output here. We notice that what happens. So in your code, you don't want a particular function to mistakenly change the configuration of your input or output. This might lead to some runtime errors as that you wouldn't be expecting, and it will be hard to debug the code. Actually, in here we are lucky to have a debugger, but on the actual Arduino IDE, it doesn't really come with a good debugger for you to use, and you need a proper interface debugger to run debugging. So good practice is to use declare this as constant, and if anybody or any function try to change it, you notice that you will get an error in this particular case because we try to change constant value. But the good thing about the constant using constant is that variables get loaded into RAM. But RAM, we have only like 2K worth of RAM in the 80 megabytes, which is the chip we are using. So RAM is actually precious. So precious RAM, right? That's where the program code gets loaded. But it has dedicated space for program code. So if you use const, most compilers will try to load variable into program code. So basically, you save precious RAM space. So that's the benefit of using the const keyword. Okay. So that done, let's make life easy for ourselves with our famous copy and paste. But this the block code. So that'll be our step one. Guys, if you were here in the first week or if you catch up with the lecture notes, please know that this squiggly line simply means the pin can use pulse width modulation. It can be used as an analog output, but it's not pure analog, it's just using a technology called pulse width modulation, but the actual pin is pin 9, digital pin 9. You can just simply hover it and you see it on there. So the good thing is that in the Arduino board, the physical Arduino board can communicate with the computer via the serial interface. So we're just simply going to use call the serial port by using serial begin function. And this function can be found on the Arduino website as well. If let's say you go to let's say Arduino references English, and you will notice that these are all the functions you can call from Arduino. So it makes it's basically usable functions that you can have access to. So you have the serial functions on there and on here, so you can use different serial functions. And we are simply calling the begin function. So you notice the serial begin function takes in the communication speed, just establishing communication between the Arduino and the board for us. But I don't like sharing the